We've been talking about parabolas for the last couple of days. Now here's this guy I happen to have met at a conference I went to. His name is Dan Meyer. He took a stop motion photograph of shooting this basket. Okay, now notice the ball is far apart here, but then it comes close together here. And when we throw something, it goes up really fast, and then it kind of slows down at the top, it comes down really fast. But what he's really interested in is this point right here. What is that point? 1910. Oh, the rim of the basketball hoop is 10 feet off the ground, and he must be, oh, if you look at it, yeah, he is 19 feet away from the basket. Now here's the equation. Okay, that equation looks pretty complicated. And also, when would you use something like this? Well, if you play video games and say you throw a grenade, how do they make that grenade look real when you throw it? Oh, probably something like this. Interesting. Okay, now let's do something that's a little bit simpler, something that we can get a handle on. Okay, I'm going to go to the next slide, and let's do a problem that the type of problem we've been trying to tackle. So here's an equation of a parabola. It's called a quadratic equation. What we're going to do is we're going to see if we can kind of sketch the graph of this equation. That's the big deal. And the way we do that is to find the zeros. Okay, now let me see. The first thing we got to do is factor it. So I'm going to do that real quick, and I'll show you my work in just a second. So here I did the factoring, and I think that most everybody in the class is pretty okay with this. You have this diamond problem here, and you say, okay, x squared times negative 24, that goes there, this number goes here. Two numbers that multiply together to give me negative 24, but if I add them, I get negative 2, and there it is. 6x times, well, negative 6x times 4x gives us negative 24x squared. And if we add them, we get this. This is all review. So then I make this area model. X times x is x squared. X times negative 6, negative 6x, 4 times negative 6, and all that stuff. And I'm doing this really quickly because I think that we're pretty okay on this. Okay, so we factored it. And we end up with these two things. These two things multiplied together give us this right there. Okay, so I'm going to go to the next slide and we'll try to clean this up a little bit. What we really want to find out is what values for x, right here, what values for x, if I plugged in an x, would I get 0? In other words, right here, I want to make this thing equal to 0. So what value for x makes this whole equation equal to 0? And what we did is well, it's kind of hard to figure this out when it's in this form, and that's why we factor. We break this down. This equation can be rewritten like this. Oh, okay, now I can take it part by part and say, what makes this equal to 0? Well, if I had x equals 6, and plugged it in right there, I would get 0. And then, of course, on this side, if I plugged in x equals negative 4, what would happen? Plug that in here for the x, negative 4, positive 4, that's a 0. 0 times anything is 0. So now we've got these two things. We've got when x equals 6, y equals 0 if I plug it in. If I plug in a 6, I get 0 for the whole equation. And then also, if I plug in a negative 4, the answer is 0. I'm plugging in that number. I'm substituting in. I think maybe that's where people are a little confused. I'm taking this 4 and plugging it in for x. Here and here, I plug it in both places, but I don't really care because if this is 0, 0 times anything is going to give me 0. That's why we call them zeros, the zeros of the equation, right here. And then the other one is if I plug in, right here, this number, it's kind of a trick. This number tells me where it crosses the y-axis, because if I plugged in 0 for the x's, what would I get? X is 0, y is 0, 0. All we're left with is negative 24. Y would equal negative 24. And there you have it. You have your 3 zeros of the equation. So just to review, this shows us where it crosses the y-axis. We factor, and we find out, oh, okay, that's where it crosses the x-axis. Let's do a little graph. So with that equation, we end up with these places, these critical points, I call them, but it's basically where it crosses all the lines, I guess you might say. So let's do this. Let's make a graph. So it looks kind of like this, and maybe I'll do this over here, just a rough estimate of what this graph looks like. There's the x-axis and the y-axis, and we're going to have, let's see, so we're going to have a point at negative 4, 1, 2, 3, 4, negative 4, and we have a point at 6, 1, 2, 3, 4, 5, 6, and then we're going to have a point way down here. I'm just going to pretend, because I don't have enough room, that that is negative 24. Okay, so we've got these places, and let's see, we'll do this in blue. Here, here, and here. So let's make a graph. So the graph would come down here and go through all those, probably go, turn around, and come back up this way. Just a rough estimate of what this graph would look like. And you only need 3 points, and that's how you do it, by using factoring. Okay, I hope that kind of clears things up. I'm not sure, but that's what we've been working with, and if you need more help, just rewind this video and watch it again. Stop it, review it, and do it. Okay, bye.